Welcome to part 5 of Competency 13. In this video, we will work with area and perimeter of composite figures. Okay, before we begin, number 1, let's take a look at this equation. This is actually the equation for arc length. In prior videos, we showed you the section. Section and the area of the section, and we also discussed the arc length. However, what we were doing is we were working that proportion where they gave you the value of the arc length. In this situation, we need to find it for ourselves, okay? So let's move up a little, but keep that equation where we can see it still. Okay, number 1, what is the perimeter and area of the figure to the nearest hundreds? Okay, well, the first thing that we should do that would be beneficial would be to find the perimeter first. Okay. All right. So what we need to do is think about what do we need for the perimeter? Well, I see 5, I see 14. I know this is 5. And I will highlight this arc length that we need. We need to find it. But we have one length left. And how do we get that length? Well, 4, as you can see, is equal to the radius of that circle. If we had the whole circle, I still wrote the wrong thing. I'm not sure why I'm doing that. Okay. Okay, let's call that R for radius. Okay, so if this is 4, if we have this 4 and we're talking about part of a circle, then that dashed line is 4 and 14 minus 4 is 10. So this gives us that length as 10. Now we have enough to gain the perimeter. Okay, so we know that our perimeter equals 5 plus 5 plus 14 plus the 10. Okay, plus the 10 plus, let's see, what do we left? 5, 5, 14. Oh, 4. And whatever that arc S is going to equal. Okay? So when we'll just add all that up at once. So let's find our S. Let's solve the equation they have above. Okay? So that's S equals 2 times 4 times the pi times this proportion. Okay? Now, that angle is the same central angle we had discussed in prior videos. So again, that is 93.2. So we'll use that proportion again just to kind of, because we're going to recap for area, how to get that area of that sector, that circle sector. Okay, so we can put this in the calculator, okay, and then add that to the perimeter, the whole formula for the perimeter, and at least we know what that is. And as you can see, once we know that, we can eliminate 2 of our options, okay? All right, so we have, oh, and you know what? I'm looking at our options. Our area is in terms of pi, but the perimeter isn't. So we don't need to worry about pi for this one. So let's just put it all in the calculator. 2 times 4. Uh-oh. Well, yeah, no. Let's go ahead and do multiply. And now, second, caret up. See, I was going to put it all together, but let's put it in the way I wrote it so you see it. Now, let's go times parentheses. So 93.2 divided by 360, close our parentheses. Okay. And that is going to equal just about 6.51. Okay. But if we have it in the calculator, now let's add everything together, okay? So that's plus 5 plus the 5 plus 14 plus 10 plus 4, okay? So that's all of the numbers. And then above that, we're adding it to our 6.5, da, 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 da. and press enter. And that's what we have. We round a bit. Okay, 44.51. Yes. So that means that C and D are no longer options. Let's put this down. 44.51. Okay, we have that. Now we can deal with area. We'll scoot it up because we're done with that formula. Next, we're going to use the proportions that we had worked with in prior videos. Okay, so what is our area? Our area will equal 5 times 14. Then we need to add that to the area of that sector, circle sector. Okay, so we don't know what that is quite yet. So let's see what that's going to be. Let's set up our proportion. Okay. Okay. And I will highlight that. We're looking for this yellow right here, the whole thing. Okay. Let's just call that just area. Okay. Well, just call it A. Okay. Actually, no, let's not. Let's call it small a to help with confusion. Okay. Let's call it small a. We can call it anything. X. X is better. There you go. That's what we're doing in prior videos. So I need that area X, okay? So how do we do that? We need X, okay, over the entire area of the circle. I know we don't see that whole circle, but let's pretend like it used to be there. Okay, so what is that? 4 squared pi, because our radius is 4, okay? And now this proportion above, this right here, we just bring it down and use it again, okay? 93.2 over 360, okay? Now, notice our areas in terms of pi. So we need to keep our pi intact, okay? All right, so we have 360x equals. Now, what are we doing here? We're really taking 93.2 times our 4 squared, but we're going to leave our pi. Okay, so what do I want to do? I want to divide both sides by 360. Both sides by 360. But really what we're doing here, let me kind of rewrite this so you see what we're doing. Pi is just going to like tag along, okay? All right, and then this becomes 1, so it cancels out. So now we can get the value of x, which is going to be all of this, okay? So let's write that in here for our area. Actually, we could just say that we're adding the value of whatever x is, okay? Whatever x is, okay? All right, well, let's get that. So you see that happening, and then we'll add the other parts to it. So our area will equal, all right, now to do this, let's do the numeric values, okay? So we have 93.2 times 4 to the second power. Since that's all multiplied together, I can go ahead and use my division, 360. Okay. Let's see if we can get that clean. Let's clean that up. Remember how to make that just a fraction. Okay. So go math and see where it says fraction. Push enter. Enter again. Okay, but it doesn't give us our whole number. If you remember other videos, we can get that. Go alpha window, arrow over, and it's number 3. Okay, push enter. And there we have something tangible. So what is the actual value of x? Is 432 over 225 to the pi. Okay, All right. Okay. So we're going to take that. Now we have that 4 and 32 over 225. Okay. And we add that plus in parentheses 5 times the 14, close our parentheses. Oh, we're going to have to do it again. Okay, alpha, window, arrow over, number 3, enter. There we go. 74. Now don't forget the pi. Remember, this is just a numeric part. We're letting pi tag along, okay? So we have 74 and 32 over 225 and pi tagging along at the end of things. Okay. Well, now we have an option. That would be B. Okay, because A is too large. Okay. All right, great. Now we can move on to number 2. Number 2. What is the perimeter and area of the figure below? Okay. Well, let's do the perimeter first. And we know that this should be 5. So if we add all those up, actually, we don't even need to write them down. What we need is all these values, okay? So that would be, let's start with the 5. 5 plus 12 plus 5. 5 plus 12 plus 5 plus 14 plus 4. So we have 1, 2, 3, 4, 5 numbers. 1, 2, 3, 4, 5, and push enter. That should be 40. Well, obviously, oops, that eliminates these 2 options. Okay. Now let's talk area. The area will be the rectangle plus the triangle. Okay. So let's go ahead and just do this in parentheses. That gives us 5 times 14, close your parentheses and add, parentheses again. And then what do we have? Well, actually, this will be 14. Okay, so we have 3 times 14 divided by 2. So 3 times 14 divided by 2, close parentheses and push enter, 91. That gives us option A. Okay, now let's go to number 3. All right, you noticed I didn't write anything down. For something that simple, it really shouldn't be necessary. Now, this next one, this is a little different because we have the circle. So we are adding this semicircle. So I want to write this one down. Okay. All right. Well, I don't think it matters if we start with the perimeter or area, but let's do the perimeter first. Okay. All right. So we need to make sure that we're seeing this correctly. So this perimeter, the perimeter will be equal to 4 plus 16 plus 4 plus, okay, circumference divided by 2. Okay, so we need the circumference. Well, we know the radius. That would be half of 16, and that's 8. So that will be 2 times 8 times the pi. And I see a cancellation right here and here. Okay. So then the truth is we can put in get rid of this right here. So you see it's gone. And just put all that into the calculator as you see it. Okay, let me do that. 4 plus 16 plus the 4 plus 8 caret second caret up, enter. 49, okay. Well, 49.13 and rounding down. So that gets rid of A and B. Great. Okay. So that gives us 49.13. Well, by the way, that is not exactly equal. It's an estimate. As my daughter likes to say, that's a guesstimate, mommy. Okay. She says guesstimates are her favorite thing at school. Yeah. Okay. So now we need our area. Well, we can get that area very easily. That is going to equal 2 times 16. Okay. Plus the area of the semicircle. Again, we are dividing by 2. And in this case, that's 8 squared pi, all that. Okay, so that area, right, and did they leave it in terms of pi? No, they didn't. So we are estimating. We're getting a decimal. So it'll be one of these decimal values, okay? All right, so let's go ahead and put that in the calculator as we see it. So I have 2 times 16, close my parentheses, add, and then parentheses, and I have 8 squared, carry it up, pi, divide by 2, close my parentheses, enter, and there you go. It will be the 132.53, which gives us option A. Okay. All right. Great. All right. We can move on. Number 4, using the figure to the right, what is the perimeter and area to the nearest hundredth? Okay. Here's the deal. Let's look at the perimeter first. For the perimeter, we have, okay, the perimeter equals 50 plus 50, okay? Now, plus, don't waste your time and effort. If you look carefully, we have 2 halves of a circle. So when you calculate this, all you need to do is add a rectangle to a circle. That's really what we're doing. So really, what do we have? Area equals rectangle plus circle. And perimeter equals, hey, this is where you have to be careful. You have a top of 50 plus a bottom of 50 added to that area of a circle. Okay? All right. That's one way to look at it. That way when you're calculating, you don't make mistakes, which it's very easy to say, okay, well, I'm going to have the perimeter of the rectangle plus the circle. No, that's really not what we're doing. Okay, so what does that mean? All we need is circumference. Well, we know the radius. If this is 20, I'm going to put it over here. Then our radius is 10. So we need, well, it's just a coincidence that we have 2 times 10, which is 20 all over again, and then times our pi. Okay, that'd be d pi. Okay, sometimes that happens. It is a coincidence. Okay, great. So let's calculate that perimeter. Okay, so we have 50 plus 50, and then plus, because all of those are multiplied together, I really don't need parentheses, so I can say 2 times 10 times second, carry it up. Exactly how we have it, and that gives us, now be careful with the numbers. I can see that A has the 2 and 6 transposed, so we don't want to do that. And B is completely wrong perimeter. That leaves us with C and D. Okay, so we have roughly 162.83. Great. Okay, so let's move on. Now we need area. Okay, so for the area, we have, right, the area would actually be the 50 times the 20. Then we're adding that to the circle, which is 10 squared pi. And are they leaving it in terms of pi? No, they are not. So that will be an approximate. So we can just enter that in the calculator the way it is. We don't even really need the parentheses, to be honest. Okay, so let's do 20 times, oh, I'm sorry, 50 times the 20. Said those backwards. Okay, now add 10 squared, second caret up. Let's double check. That's everything we need. Let's push enter. And that gives us option. Oh, the numbers are so close. Don't let your eyeballs cross. I'm going to mark out that D. That is incorrect. Our option is C. Okay, great. Now, number 5, we're going to change a little. In this situation, this is a composite figure. And let's see what we're being asked. Using the figure to the right, what is the area of the shaded region to the nearest hundredths? So we have a situation where area is this. The area equals the trapezoid minus the circle. Okay? All right, now I have learned my lesson when I was teaching 7th grade is when we introduced this. My 7th graders thought that you add those two together. You have to explain to them that we are cutting out the circle. We have a trapezoid and we cut out the circle and it is tossed away. They thought that it's the circle on top of the trapezoid. I don't know why. I didn't see it that way, but that's how some people see it. So I'm going to reiterate, we are subtracting. And this is why I draw it out the way I do. Okay, so let's get the area of the trapezoid. So we need the area of the trapezoid. And that will be, okay, if you remember, what are we doing here? We are dividing everything by 2, but we need to add these 2 bases. So we're going to add the 9 plus a 25 and then multiply it by a height of 10. And we can pop all of that in the calculator and we get that. So let's go ahead and do the circle while we're at it. Okay. And the area of the circle equals, well, our radius is 4. So that's 4 squared pi. And is it in terms of pi? No, it is not. So we will get an approximation. So our entire area, really that answer will be an approximation. Okay, so put it all in the calculator and get it over with. Okay, so what are we going to have to do here? I'm going to go ahead and use parentheses, 9 plus 25, close my parentheses, and we are multiplying that times 10. Really, we could have multiplied that by 5, but 10. And then our order of operations is safe. We can say divide by 2 and push enter. 170, and I agree with that. Okay, 170. That means that option B is incorrect. They're trying to trick you. So what we need is 170 minus whatever the estimate of the circle will be. Let's do that. So 4 squared, okay, second caret up, push enter, okay. Oh, and that gets rid of C. They're trying to trick you again. And those kind of answers, those seeing if you're doing it correctly and you understand it, they will put the area of the trapezoid and the area of the circle separately as answer choices. And the point is, you should know how to deal with any composite figure. Okay, they put 2, 3, and it's actually 2, 7. Okay, it wasn't even completely right. Okay, so now let's subtract that 1.27. So we've got A and D. So this is what I'm going to do. I'm going to say 170 minus, I'm going to go up and capture my prior answer for my circle, bring it down, push enter, and I get 19 points. Yeah, that's great. Worked out great. And it's option A. Okay, let's keep going. Using the figure to the right, if the length and width of the rectangle are 7 and 3, it will be 7 times 3. What is the area of the shaded region to the nearest hundreds? Okay, so as I said, this would be 21. And what are we doing? We need, we're going to have to use Heron's formula. Okay, I'll go with it, through that with you. Not a big deal. So to get this area, we have the area equals the triangle minus the rectangle. Okay. So, and looks like we're going to be estimating because I see some decimal action going on. Okay. So we already have the area of the rectangle. That was 7 times 3. Oh, not 27, 21. Ooh, I bet you saw that and said, oh, there we go. 21. 21. Okay, so we need to use Heron's formula to calculate the area of the triangle. So we need S. Okay, and if you don't remember what this is, look it up. Here, I'll write that down for you. Let me write that up here. That is Heron's formula. Okay, and you can look that up online. All right. So we need S. How do you get the value of S? Okay. So we need to, because we use it in the formula. So you take 12 plus the 13 plus the 15. You divide the whole thing by 2. Okay. 12 plus 13 plus 15. And that's it. Push enter and we divide by 2. That is 20. So that value that we need is 20. It's very important. If I could make it look like an actual 2, that'd be great. Okay. All right. So what is the formula? This is what we need. We need, we're talking area. This area of the triangle equals all under the square root. That will be 20, which is our S. Then in parentheses, 20 minus the 12. You multiply 20 each side subtracted from the 20. Okay? So then I have 20 minus 13. And then 20 minus 15. It's all under the radical, and it will be an estimate. Okay? All right, and we take that and we subtract the 21. But let's go through this process first. Okay. Under the square root, we have 20. In parentheses, 20 minus 12. And yeah, I could do some of this in my head. But when you're testing, don't risk it. I've learned my lesson. You think you did things right, and you didn't because you get tired. So 20 minus 15. Okay, now let's look and make sure all my values are correct. I have 12, I have minus 13, I have minus 15. Verify those are actually the values of the sides of my triangle. Okay, now we can push enter. Okay, so that's just the triangle area. So as you see, A is not an option. Okay, now I want to look at these. Just take a look at what the options they gave us. We're taking the area of a triangle and subtracting 21. This means that our answer cannot be over 74 or even 70. It cannot be larger than, let's say, 75. Well, this automatically gets rid of C and D. Okay, just to make us feel better. Okay, I'm going to write this down. 74.83. Okay, and that's the area of our triangle. All right, so let's subtract 21, which is the area of our rectangle. Okay, minus 21. And it is 53 point. Okay. Do you see what I did? I took a look. I actually paid attention to what my answers were. I'm like, well, there's no way. That's impossible. Okay, so it is option A. All right. I mean, not option, I'm sorry. The area is option B. All right, let's go to number 7. Okay, this one's a tiny bit different. All right. So it says let's get rid of that. Okay. Using the figure to the right, if the rhombus lies inside the circle, okay, with diagonals that are 8 and 5 inches, and the diameter is 14, and they mean the diameter of the circle. They mean across the circle. Okay. What is the area of the shaded region? Okay. So what are we really doing? This is what we're doing. We're doing the area equals the circle minus the rhombus. Okay. Well, how do we do that? Well, we know from the 14 that our radius is 7, and we need to square that. I can draw that in. This would be 7 because they gave us 14. So to get the area of the circle, 7 squared pi minus the rhombus. Well, that is 8 times the 5 divided by 2. Okay? Now, all we need to do, and it's not left in terms of pi, so that means we will get an estimate. And we just put that in the calculator as is. Okay, so 7 squared, carry it up, and subtract. I'm going to put this in parentheses. Okay, we have 8 times 5, or 5 times 8, however you want to do it, and divide by 2, which that's okay with order of operations. Close our parentheses, push enter. And do we have a taker? Yes, we do. 133 right there. Okay, right. I'll write that in if it makes you feel better. 133.94. And it does round to 94. Okay. All right. This is the last question in our video. Once again, I've noticed people are starting to watch more. I so appreciate it. With that watching, showing your appreciation, don't forget to like us and share us and subscribe. And if you know someone else who might subscribe because they need to practice for the test, share with them. Think about it so they can join us and we can keep these things coming because we have more things we'd like to develop, other free formats, free, besides free videos, free things you can print out, and more forms where it's free, where you can get instant results with many different types of questions and keep the studying coming so we can all be successful. With that, happy testing.